Okay, this is from The Hidden History of Health by me, Pete Rogers. We're going to talk about blood flow to the brain and causes of dementia. This is a capillary in the brain, and you see the red blood cells traveling through the capillary. The blue circles are the oxygen going to the tissue, the neuron, the brain cell. The yellow is the capillary basement membrane. The green is the vascular smooth muscle in the brain. They're called pericytes. Typical capillary is about 5 millimeters in diameter. Typical red blood cells about 7 millimeters in diameter, so it has to fold back on itself to form a little bit to fit through there. Chronic diabetes will cause thickening of this part here, the yellow capillary basement membrane, so you see fewer blue circles able to get to the brain cells, so you get less oxygen delivered to the tissues with chronic diabetes. You get hypertrophy of the vascular smooth muscle level with hypertension. You'll also get fibrosis in there, scar tissue, collagen deposition, leading again to decreased oxygen delivery to the tissue. So these are just some of the ways that as a person gets older and accumulates worsening complications from diabetes and hypertension, obesity, and atherosclerosis, they're getting less and less oxygen delivered to their brain cells, and eventually those brain cells will start dying off. They won't be able to have enough oxygen to make adequate amounts of energy to maintain their ion gradients. Okay? Now this is showing what blood flow to the brain looks like. Okay, the internal carotid artery goes up into the brain. It'll split into a middle cerebral artery goes along the outer surface of the brain. An anterior cerebral artery goes down the midline of the brain. I didn't draw it in because it would make the picture too complicated. The outer surface of the brain is curved like your head is curved. That's called a convexity. So this is called a cerebral convexity. Okay, there's 3 levels of brain tissue that are relevant. There's what's called the basal ganglia, the deep gray matter nuclei where all the cell bodies are. Right down here you can see them drawn in gray. At the level of the lateral ventricles, the blue part here, that's called the corona radiata. It looks like a crown and it radiates around in a circle. And then above that is called the centrum semiovale, the deep white matter, because it's in the center and it's semi-oval in shape. Those are the 3 brain levels we talk about. One of the things I do is I'm a neuroradiologist. Okay, I also did half a fellowship in endovascular brain surgery. I've seen many tens of thousands of these things. Okay, the skull and crossbones is drawn right here at the central part of the brain in the deep white matter because there's not a lot of collateral blood flow here. These arteries coming from below are called lenticulostriates, and they barely get up in that area. These arteries up on the convexity that penetrate the brain are called the penetrating arteries. And it doesn't take much to drop blood supply to the skull and crossbones area, and the patient gets a little stroke. In any given day, I'll see thousands of these, hundreds or thousands of them. That's how common they are. Lots of them are little, and it's, Uncle Joe's moving kind of slow at the junction. Just old people slowing down, getting stupider, slower, more fragile, and weak. Okay, so you don't want those little small strokes, but they don't necessarily cause a hemiplegia, big fixed deficit. They're small strokes. Okay, so anyways, what's going on is why do we have a blood pressure to get blood to the top of our brain, the cerebral cortex, to pump that blood against gravity? Okay, and normal blood's about the density of water, the thickness of water, the viscosity of water. If you eat a high-fat diet, it sticks the red blood cells together, and now your blood becomes thicker like a milkshake. So you got to pump higher pressure to get that blood up. If you eat a lot of salt, the sodium's a vasoconstrictor. It narrows your arteries. It inhibits endothelial nitric oxide synthase, the vasodilator. And so your arteries constrict. Now you got to pump thick blood through a constricted circuit that causes hypertension. A classic food that's high in fat, high in salt would be like pizza. Okay? So processed food tends to be high in fat and high in salt as well. Those things cause hypertension. Why do black people have so much hypertension in the United States but zero in Kenya when they ate the plant-based diet? Because in the USA they ate tons of processed food, high in salt, high in fat. That causes hypertension, okay? All the conventional medical books, they're stupid. They just say, 95% of hypertension is unknown cause, BS. We know that people don't get hypertension where they eat low-fat plant-based diets. All right, so anyways, what I'm talking about here is you basically are stuck with a Goldilocks situation, the golden mean of Aristotle. If your pressure is too high, you're at risk to damage these arteries and cause more atherosclerosis, hypertension-induced atherosclerosis. If you overtreat it and you drop your pressure too low, though, then you run the risk of stroking out the skull and crossbones area. Okay. So the best thing to do is optimize your diet so you don't have a problem with that. Oh, this was a good book. It was written by this guy right here, Blaylock, and what he said was, look, there's some things that overstimulate the brain, and he was especially focused on monosodium glutamate. It's the glutamate. 90% of the neurotransmitter in your brain are glutamate. It's excitatory neurotransmitter. It's like flipping on a light switch. Okay, so it overstimulates the brain. They put tons of MSG and also MFG, manufactured free glutamate, into the food because it makes it taste good. Our ancestors worried about starving to death. It was hard for them to find a protein source of food. So when they found one, the glutamate amino acid would sort of activate the glutamate receptors in their mouth and in their intestinal tract as and activate reward neurotransmitters, so they'd want more of it. You can take a stale food, add MSG to it, and it'll taste good. It's another reason why processed foods are bad. Many of them are stale and they just have MSG added to them. But he was concerned that by overstimulating the brain cells, it can cause what's called excitotoxicity, stimulate them to death. And that's why he calls it excitotoxins, the taste that kills. And he's right about that, and he did a good job bringing attention to it. It was John Olney back in the 1960s figured out that MSG was a major excitotoxin, overstimulating brain cells. But it turns out there's a lot of other excitotoxins, things like aspartame, the artificial sweeteners and excitotoxins, things like glyphosate, the herbicide, in Roundup on the non-organic food, that's an excitotoxin. Beta amyloid protein, which accumulates in the brain in higher amounts when you're sleep deprived because you can't remove it, or when you're eating high-fat diets because you use up insulin-degrading enzyme. You get hyperinsulinemia when you eat a high-fat diet because it causes insulin resistance. And then insulin-degrading enzyme in the blood in the peripheral part of your body gets used up in the removal of the insulin, and you can't make enough of it. It also is what's supposed to clear out from the peripheral blood the beta amyloid protein. So beta amyloid protein re-enters the brain, crosses the blood-brain barrier, and exerts an excitotoxin effect. Okay, leaky gut will also lead to an excitotoxin-like effect. When you got leaky gut, you'll have leaky blood-brain barrier simultaneously, and the bacterial endotoxins, LPS from gram-negative bacteria, LTA from gram-positive bacteria, will get access to part of your brain, and then the macrophages overreact to them, and it leads to an effect much like excitotoxicity, attention deficit medicines like excitotoxicity. Okay, there's more ways you can get excitotoxin effect. We're not going to get into all that right now, but I'm just alerting you to that concept, because what's happening here is you're screwing your brain cells. Okay, hypoxia will also lead to an excitotoxic effect as nearby infarcted brain cells release their glutamate into the extracellular space. Okay. Oh, this lady wrote a good book about it. This lady is Catherine Reed. She's got a good TED Talk. Catherine Reed, she's a biochemist specializing in protein biochemistry, and her daughter had mild autism. So what she did was she figured out how to get monosodium glutamate out of her diet, the kid's diet, and the kid got better, the kid was cured. Okay, and she went through all the MSG substitutes. There's a whole bunch of things that have these like secret code names, and they're really just MSG or MFG. And it's all kinds of things you'd be real surprised, like citrate, barley malt, malt extract anything, okay, quite often it's that. Isolated soy protein, hydrolyzed soy protein, okay. I won't eat soy sauce or any of that kind of stuff. This is one of the reasons why, because it'll tend to have MSG or MFG in it. Okay, what the food companies do is they titrate the foods until they reach something called the bliss point. They try to they bring in a research subjects, a bunch of people that volunteer, and they'll vary the amount of salt on there, the amount of MSG, MFG. They'll add things to it to get the right mouth texture. They'll fry it, whatever they can, high fructose corn syrup it, to get the bliss point where people are most want to keep on overeating it or to come back and want more. Okay, so that's why they say you just can't eat one of these Lay's potato chips or something, because they know how to make it taste real good. But you get that pleasure initially, but in the long run it does you damage. It would be kind of like looking at a beautiful looking prostitute. She might look pretty good, right at that moment, but the consequences are HIV, gonorrhea, chlamydia. It ain't worth it. You don't want to eat this crap. Okay. And then this is about MFG, manufactured free glutamate. So all that your brain cares about is the glutamate. It doesn't care about the monosodium. Okay, so the more you process a protein by pasteurization, extraction, hydrolysis, fermentation, the more you free up the individual glutamate molecules and you activate these glutamate receptors in your intestinal tract. And it gets into your blood, it overwhelms your sequestration system and your gut lining, and it'll get access to your brain. Quite often simultaneously you'll have leaky gut and leaky blood-brain barrier, and this glutamate's getting increased access to your brain. Even if you don't have that, you still got circumventricular organs in your brain that are chemosensors that don't have a blood-brain barrier. Okay, in the area posterior in your brainstem, your vomiting center, that doesn't have a blood-brain barrier. Okay, and some foods, especially gluten, is very high in glutamate. So is casein, soy, and whey. They can and corn proteins. They'll extract it from them to generate MFG, and then they'll add that to the food. Okay, so that's it for today. I hope you found that helpful.